Let's take a look at this example. We have again a rational function. We're supposed to look at the denominator first. I'm going to replace x by 0. I'm going to have square root of 4. Square root of 4 is equal to 2 minus 2 is 0. We said we do not want to have 0 in the denominator. So what we're supposed to do? We're supposed to simplify this function. How I can do so? By multiplying the numerator and denominator by the conjugate of the numerator and multiply everything also by conjugate of the denominator. So I'm going to multiply everything by the conjugate of the numerator first. Square root of x squared plus 1 over square root of x squared plus 1 and conjugate of the denominator, which is square root of x squared plus 4 plus 2, and I have square root of x squared plus 4 plus 2. Next, you're supposed to apply the formula for the difference of squares, which says a squared minus b squared is equal a minus b, and I have a plus b. You have to remember these formulas. So this is my a and this is my b. This is my a and this is my b. So the top I can rewrite as limit x goes to 0, of course, and the top of my function, the numerator of it, is going to look like this. Square root of x squared plus 1 to the second power minus 1 to the second power times whatever left. I have square root of x squared plus 4 plus 2. If it comes to the denominator, I'm going to use this term and this one. I have, this is going to be my a, this is going to be my b, this is my a, this is my b. I have square root of x squared plus 4 to the second power minus 2 to the second power and times whatever left. Square root of x squared plus 1 plus 1. So I have limit x is approaching to 0. This square is going to eliminate the radical and this square is going to eliminate the radical, and I'm going to have x squared plus 1 minus 1, because 1 square is 1, times the square root of x squared plus 4 plus 2. I'm doing everything step by step. Just make sure that everybody is going to see what's going on. And I have x squared plus 4. 2 to the second power is 4, minus 4. In the denominator, I'm going to have also whatever left. Square root of x squared plus 1 plus 1. I have limit x is approaching 0. 1 minus 1 gives me 0. 4 minus 4 gives me 0. I have x squared, open parenthesis, square root x squared plus 4 plus 2 over x squared square root x squared plus 1 plus 1. X squared and x squared will cancel out. And now let's take a look at this limit. If you are going to replace 0 by every single x, you are not going to have 0 anymore in the denominator and 0 in the numerator, so you are not going to have a situation 0 divided by 0. That's why we can simply finish this problem by replacing x's by zeros. So I have square root of 0, because x to the second power is 0 plus 4, this is 0, plus 2 over square root of 0 plus 1 plus 1. Square root of 4 is equal to 2 plus 2 over square root of 1 is 1 plus 1 is equal 2. 4 over 2 is equal 2. And this is the solution to my problem. We have another example. Again, we have rational function and we have more square roots. Again, you're supposed to look first at the denominator. If you are going to replace this x by 0, you are going to have square root of 1. Square root of 1 is equal 1. 1 minus 1 is going to give me 0. We said we do not want to have zeros in the denominator. That's why we have to simplify this expression. How I can do so? By multiplying everything by the conjugate of the numerator and conjugate of the denominator, because we want to eliminate the square roots. We want to eliminate the radicals. That's why I'm going to have square root x squared plus 1 plus, because I have to find the conjugate of the numerator, x plus 1 over the same thing, x squared plus 1 plus square root of x plus 1 times the conjugate of the denominator. And you will have 1 plus square root of x plus 1 over 1 plus square root of x plus 1. Next, copy down limit x is approaching 0. Now you're supposed to again use the difference of squares, and keep in mind that the formula says a square minus b square is equal a minus b, a plus b. This is my a, this is my b, this is my a, and this is my b. That's why I'm going to rewrite this as square root of x squared plus 1 to the second power minus square root of x plus 1 to the second power times everything whatever left. In this case I have 1 plus square root of x plus 1. This is my numerator, and in the denominator I'm going to have 1 square minus square root of x plus 1 to the second power. Okay, because this is my a, and this is my a, this is my b, and this is my b, times whatever left. I have square root of x squared plus 1 plus square root of x plus 1. This square is going to eliminate radical, and this one is going to eliminate this radical. This square is going to eliminate this radical. Copy down everything whatever left. I have limit x goes to 0, and we have x squared plus 1. I'm going to have negative times positive gives me negative x. Negative times positive gives me negative 1 times 1 plus square root of x plus 1 over, I have 1 to the second power is 1. Negative times positive will give me negative x. Negative times positive gives me negative 1. Copy down everything whatever left. I have square root of x squared plus 1 plus square root of x plus 1. 1 minus 1 will give me 0. I have limit x approaches 0, and in the numerator I'm going to have x squared minus x, and I have 1 plus square root of x plus 1 over x. 1 minus 1 gives me 0, and I'm going to end up with negative x. And in parentheses, I'm going to have square root of x squared plus 1 plus square root of x plus 1. Factorize x from these parentheses, and you're going to have limit x is approaching 0. I have x. Inside of the parentheses, you're supposed to get x minus 1. And I have 1 plus square root of x plus 1 over negative x square root of x squared plus 1 plus square root of x plus 1. X and x will cancel out. Now, if you are going to replace every single x in the denominator by 0, you are never going to end up with 0 in the denominator. That's why we can simply go to the end of the problem by replacing every single x in our function by 0. I will have 0 minus 1, 1 plus square root of 0 plus 1, close parenthesis, divided by negative, open parenthesis, square root of 0 plus 1 plus square root of 0 plus 1, close parenthesis, and of course close parenthesis over here. And we will have negative 1 times 1 plus square root of 1 is 1 over negative, open parenthesis, square root of 1 is 1 plus square root of 1 is 1. And I'm going to have negative 1 times 2 over negative 2. Negative 2 divided by negative 2 is equal 1. And this is the final solution to my problem.